Welcome again to my YouTube channel on Engineering Mathematics Made Easy. We continue with trigonometry. From where we left, we are in question number 1. All the others we were doing were examples. So now we start with the first question. What is tan A in the trigonometric function shown? So for this one, you expand this one as a compound angle, and then you're going to get that. So this one will be now tan A minus tan 45 all over 1 plus tan A tan 45. But tan 45 from our special triangles, it is equals to 1. So we write like this: tan A minus 1 all over 1 plus tan A and then 1. So from there we can say let tan A be equal to y. So we will get y minus 1 all over 1 plus y, like that. And this one we are being told is supposed to be 1/4. So we cross multiply. This one we get 4y minus 4 is equals to 1 plus y. We can now bring this y this side. So if we bring this y this side, you get 3y, because it will be 4y minus y. While we bring this 4 to this other side, it will be 5. So finally we get y is equals to 5 all over 3. And this is our answer, because y is the same as tan A. So we get that from that, and that's what we are getting here. Tan A equals to 5 all over 3. We go to the next question. Prove the identities. So the first identity we prove, we come and say cos, we are proving this is equals to that. We say cos theta, we factor out cos theta, we get 1 minus cos cubed. When we factor out, this one is going to remain as cos squared theta. This is all over sine theta. Remember, this one is from trigonometric identities, is supposed to be sine squared. So this is sine squared theta all over sine theta. Now we can cancel that. We can also cancel one of them. So finally we end up with the cos theta sine theta, cos theta sine theta. We come and do this other one, and this is how we do it. We start with, we say you can expand this one and this one in terms of, like, for example, cos, instead of 4 theta, you say cos 3 theta plus theta, which is the same, plus cos 3 theta minus theta. So this one, we work out this one first. So this one will get, we expand that one as compound angles. This one will give us cos 3 theta cos theta minus, because here we have plus, we put a negative here. That will be sine 3 theta sine theta, plus we expand this, it will be cos 3 theta cos theta. Now it will be plus, that will be plus sine 3 theta sine theta. Then we can now, from there, you can see that we have this which is the same as this one. So this one can cancel that one. Then we are left with these two. This plus this is like y plus y, you get 2, and then our y is cos 3 theta, cos theta. Let's now go to the denominator. For the denominator, we have sine 4 theta. Sine 4 theta will be sine theta plus 3 theta plus sine 3 theta minus theta. We expand that one. When we expand that one, we will get sine theta cos 3 theta. This is plus, we also put a plus there. Cos theta sine 3 theta plus, we expand this, it will be sine 3 theta cos theta minus sine theta cos 3 theta. From there, we can say that this one, sine theta cos 3 theta is the same as that. So this one we can cancel because it's like saying y minus y. So this one cancels. All these ones are now supposed to be added. So we will get 2 cos theta sine 3 theta like that. So we have the numerator and the denominator. So we write those ones and see what we shall get here. We get, we write the numerator is 2 cos 3 theta cos theta all over 2 cos theta sine 3 theta. So you cancel that. Then you can also cancel that and cancel that. So we are left with the reciprocal of tan, which is cot 3 theta. So that's how we get our answer as that. So you can see cot 3 theta there. This is our cot 3 theta, and this is what we have gotten. So we follow that route from here. We do systematically, and we attain our marks as shown. And so we go to the next question, which is prove the identity. I'll do also this one and see what we can get. Prove the identity. So I write it like this. This is sine squared theta bracket sec theta plus cosec theta close the bracket. So I'll write these ones in terms of sine. I write 1 all over sine theta, 1 all over sine theta there, 1 all over cos theta. So it will be sec. It will be sine squared theta. Here I will write 1 all over cos theta plus 1 all over sine theta. This one, then you write cos theta. This is sine theta all over cos theta like that. So with that one, we come and divide this. You can divide that and that, you get 1. Then write this one in terms of, you write here, you expand this one, whereby you find the LCM. Before that, you write sine squared theta. Then this one will be cos theta sine theta. Divide that by that, you get sine theta there, and here you get cos theta, like that. Then you divide it by sine theta. This sine theta can cancel this, but will be left with 1. While this other one can also cancel this. So we are left finally with sine theta cos theta plus cos theta cos theta cos theta cos theta. So this one is 1, or this one is tan. So finally our answer is going to be tan theta plus 1, and that's what we are looking for. You can see this one is the same as that. So that's how this question is supposed to be done. Moving on to the next page, we have prove the trigonometric identities. We have that, and we have also that. So I can choose one of them. You can do this, and now I can do for you this one. This one will be like this. It will be sine theta plus cos theta all over sine theta minus cos theta minus sine theta all over cos theta. This one we are supposed to prove that this is equals to that. So what we do here, we come and look for the LCM of that. That will be cos theta sine theta. So this divided by that, you'll have here cos theta, we have sine theta plus cos theta minus this one will be sine theta, and then we have cos theta there minus sine theta, like that. So you can now multiply all this. This will be cos theta sine theta plus cos squared theta minus sine theta cos theta plus sine squared theta all over sine theta cos theta. So this one you can cancel that and that, because this one will give us 1. We shall get 1 from that. And then we have this and that. This one also can cancel. This one will get 1, but this one will get this, and that is going to cancel. So we'll be left with 1 here. The 1 will be left with 1 there, because of cos squared theta plus sine squared theta will give us 1. This other one will give us 0. So we have 1 all over sine theta cos theta. So these are reciprocal of sine and cos. So finally we'll get cosec theta sec theta as our answer. So that's what we're going to get. As you can see here, you can compare this and that, and that's what we are getting for this question. So I have done it systematically. I have awarded marks as need be. Question number 8. Given cos b is equals to 5 over 3, and sine a is equals to 7 over 25, where a is obtuse and b is acute, determine that. So we draw this one where we are saying a is obtuse. So if it is obtuse, it is going to be more than 90. So it is going to come to this side. So we know sine is opposite, which is here 7, all over hypotenuse, that is 25. So we will find this value by use of the Pythagoras. So our angle is that. So by using Pythagoras, this one will give us 24. Then we come to cos B. For cos B, we are told B is acute. So this one we use the first quadrant, which is here. This first quadrant, we draw it like this. We say cosine B is adjacent all over. This is supposed to be 5 over 13. Adjacent all over hypotenuse 13. Using Pythagoras theorem, this one you are going to get as 12. So this one, then it means this is our B. Our B is there. So we can get our sine B. Sine B is equals to, that is the opposite all over hypotenuse. Then we can also get our cos A here. Cos A is equals to, remember now that because this one is the second quadrant, we are going to have this 24 as negative because it's on this side. It's going to be negative 24. So this one will be negative 24 all over 25. And the question we ask sine A plus B. So here we will have to expand sine A plus B. This one will give us sine A cos A plus this one will be, that is cos B, that will be sine B cos A. And then we can now pick them from here. We have sine A, which is 7 over 25. We have cos B, which is 5 over 13, plus sine B, we have it as 12 over 13, and cos A, we have it as negative 24 all over 25. And this is what we are getting from here. This is our values. So when we do that problem, we will get our answer as shown. That is 253 all over 325, and it is shown there. When we work out this, we will get that. Moving to the next page, we have cos A minus cos B. So you are supposed to expand that. So once you expand that, you will get cos A cos B sin A sin B. And you use the same way we have done, where you have here you have, for example, you have cos A. Our cos A is supposed to be negative 24 all over 25. Our cos B, for cos B, we have it here, 5 over 13. 5 over 13. Then plus sin A. Sin A is going to be 7 over 25. And sin B is 12 over 13. So you do the same, and you are going to get your answer as that. So that's how you do that problem. You have this other problem whereby we are told to prove that this is equals to that. So how do we do that? We use the differences, the addition and differences of ratios. So this one will give us, if you add that to that, it will be, this one will be 2. Then we have sin B minus plus C all over 2 minus, not minus, but sin, that is cos, there is cos B minus C all over 2 divided by, for this one it will be minus 2, that is cos B plus C all over 2 cos B minus C all over 2. That's how it is supposed to be done. So this one can cancel, and then we are left with this, whereby we can cancel that and that. So finally, it is going to be, the answer is going to be the reciprocal of tan, which is negative cot b plus c all over 2. And so that's how I have done it. You can compare that answer and that is actually supposed to be the same. So this is how it has been done. So let's go to the next question. For the next question, we have solve for r. Solve for r. So what we do, we say, here we have this equation and this. We can expand this. If we expand this, it will be r sine theta cos alpha minus r sine alpha cos theta. It will be like that. So if you compare with this, that is 5 sine theta minus 12 cos theta, you find that this one is the same as that. So our 5 is equals to r cos alpha. While this one, if you compare this and that, our 12 is going to be equal to, that is negative 12 is equals to negative r sine alpha. And so we can cancel the negative there. So we can create a triangle using that, whereby you can do a triangle like that. And here we have cos alpha. Let's say this is alpha. It will be alpha is opposite. Opposite is going to be 5. Because if you take this r this side, you will have 5 all over r is equals to cos alpha. And this one is, it will be 12 all over r is equals to be sine alpha. So this one will be 5. This is going to be r. This is for the sine. Opposite. Opposite is here. This is opposite all over hypotenuse. For cos, it is going to be adjacent 5 all over r. So this is your triangle that you are going to get, and it is as shown here. So you can now write this after knowing that r, if you use Pythagoras theorem, r is going to give us 13, because you are going to have 5 squared plus 12 squared, which is going to give us 169. 169, square root of 169 is going to give us 13. So from there, we have now this equation we know is supposed to be now 13, which is this. Then cos alpha, which is now this, sine theta minus, this is now sine alpha cos theta. This is now our equation, and it is given now, this equation is given by r sine theta minus alpha, like that. So with that one, and with this triangle, we know that cos alpha is supposed to be equal to, that is adjacent over hypotenuse, 5 over 13. While sine alpha is opposite all over hypotenuse, that. So that's what we are getting. So alpha, we can get the value of alpha as now 67.38. That is, if we get the sine inverse, it is going to give us that. Finally, we are told, solve for theta where theta is between 0 and 360 if r sine theta minus alpha is equals to 6.5. So we come to the same equation we had, whereby we now say 5 sine theta minus 12 cos theta is equals to 6.5. This one we had it as 13. This one is the same as 13 sine theta minus 67.38, like that. And so we will say that 13 sine theta minus 67.38 is equals to 6.5. So we can divide here by 13. We can divide here by 13. This will give us sine theta minus 67.38 is equals to a half. Because if you divide 6.5 by 13, it's going to be like a half. So we will now be able to do this. We say theta minus 67.38 is equals to sine inverse of a half will give us this will be sine inverse a half. This one gives us that. So we are going to have theta minus 67.38, and here is going to be that degrees, because we have shifted this side, and after shifting we get that. So this is what we are now going to have to do. So what we do is that apart from that, if you check at your trigonometric unit circle, if you have that there for sine, then this other side has also another 30. That is 30. But the angle we consider is that. So it will be 180 minus 30, which is 150. So another angle we have is 150. Check in your table and see that sine 30 and sine 150 are supposed to be the same. So from there, we will say theta minus 67.38 equals to that. We get our theta. This will be 30 plus 67.38. This will give us 190. This is 97 degrees for that. And this other one will be theta minus 67.38 equals to 150. We can now move this side, so we are going to add 67.38. This one will give us 8 there. We have 3, we have 7, 1 and 2. That is 217.38. And viewers, we come to the end of our lesson. Thank you. Meet you next time.